All right, welcome everybody to today's webinar. We're going to be running through our webinar DevOps and SLSA. SLSA stands for Supply Chain Levels for Software Artifacts. And I'll be talking through a little bit about the supply chain security threat that's growing out there and some of the best practices you can use. And then we'll dive into SLSA itself and give you a little bit of a primer on what it is and how it can impact your implementation of a more secure supply chain. So with me today, I have our development team lead, Sean Rowley.
Hi all.
And he's also our point person with the SLSA steering committee as well. So he'll be able to dive in, give you guys a little bit of look under the hood. And my name is Dana Crane. I am the product marketing manager here at ActiveState. So one thing to note is we will be having a Q&A later, but if you have any questions at any point during the slideshow, please go ahead, pop open that Q&A window and put in your question, and we'll get to that a little later after the demo. So let's get started. One thing I want to start off with is our growing supply chain threat. So ever since the beginning of the pandemic out there around 2020, bad actors have realized that they can achieve economies of scale by targeting independent software vendors directly. So previously, where they would hunt and peck through thousands of corporate websites or web applications to try and find a vulnerability, they've now realized if they go straight to the source and find a vendor of a trusted piece of software, once they hack into that organization and put their malware into the software, it then gets propagated downstream to thousands or even tens of thousands of customers and installed as a trusted piece of software. This gives them the back door to get into, as I said, thousands of customers downstream. So those economies of scale are really what's driving this huge growing software supply chain threat that we've seen escalating over the last couple of years. And that comes through in a number of different vectors. Before we get to those vectors, what we wanted to understand out there is with this growing supply chain threat, how are companies reacting to it? So we undertook a survey late last year to understand how about 1,500 different organizations, big and small, worldwide, what they were doing to implement better supply chain security. As you can see from the chart on the left side here, they're not doing a very good job. What they're implementing is really not meeting the needs of that growing supply chain security threat. And the way that we determined this was we asked them a number of different questions around how they import open source software into their organization, how they build that software, and then how they consume that when they're building their own software. And when it comes to things like import security, we asked around questions like typical vectors, such as typo squatting, when somebody has created a malicious package that's named similar to a very popular package, such as Python request versus request, for example. Or maybe they're not aware of dependency confusion, which happens when you've got an internal package and somebody, a bad actor, guesses the name of that package, submits it to a public repository, and your package manager will go and look in that public repository first, find that malicious package, and download it. That's been something that's popular that's been happening as well over the last few years. Or maybe it's something as simple as author impersonation, where somebody has hijacked their credentials on a public repository and therefore create a new version of a popular package with malware in it. All these things can happen during your import routine when you're bringing those open source packages in, and you really need those controls in place to be able to understand when that happens and be able to counter that threat. There's also build security issues. A lot of our respondents actually don't bring in pre-built packages. They bring in source code from the public repository, but they then need to make sure that things are built securely. You need to understand those install scripts, whether they've been infected or edited. So malicious build scripts are things to look for. Or even dynamic packages that pull in resources remotely when they're being built. another key vector that can happen during the build process. And finally, when it comes to consuming those packages that you've built, making sure that they're signed and not compromised. One of the key poster childs here is SolarWinds, who were compromised prior to the signing step. So it looked like a signed and good package, but it was actually compromised. And then finally, how do you verify those packages before you consume them to make sure that what you've got is what you think you've got? And we'll talk a little bit more about attestations later. Another key area of concern that came back from our survey was around public repositories. There's still a lot of organizations out there that implicitly trust the repository. And that's despite the fact that public repositories offer no guarantees as to the security and integrity of what they're providing. You've got thousands or even tens of thousands of authors producing, literally millions of open source packages out there, and you've got to be able to trust them all if you're bringing in something that's pre-compiled, that's pre-built. Those are typically unsigned. There is no signing mechanism attached to most public repositories. So it's really kind of a wild west, and implicitly trusting the repository may not be the best way forward. Another area of concern was around how builds are reproducible. We found out that by count, only about 22% of our 1,500 respondents actually create reproducible builds. And that's a worry, because if you can't reproduce the build, there's no guarantee that what you started with, the components you started with, weren't compromised in the first place. And certainly reproducible builds require a lot of time and resources. And for most of the companies that were in our survey, the small projects they were running, they would only ever build those dependencies once. So unless there was a critical vulnerability, they wouldn't go back and rebuild it. Therefore, the time and resources needed to create a reproducible build system really didn't make sense for them. So the problem here is, if you rarely update or maintain those dependencies once they're added to your code base, you've got a definite problem going forward. So reproducible builds is something to look at. If you can't afford the time and resources, we'll talk a little bit about how you might be able to leverage our service to get that same kind of security model without investing the time and resources. So what we want to understand right now is, how would you rate your supply chain security? So we popped up a little poll here, and it just gives you 3 different choices. And this was the same sort of ranking we used for our survey when we went out to our 1,500 customers. What we really want to know is, do you think your supply chain security maturity level is right now poor? In other words, you're importing pre-built binaries, pre-built packages directly from the public repository, maybe without so many checks and balances on that. Or maybe you're building everything from source code, but maybe you don't do it in a reproducible manner, or you don't have a lot of explicitly secured or audited software behind that, audited processes behind that? Or do you think you have more of an excellent security rating at this point in time? You're doing everything in a reproducible way, and you audit your infrastructure on a regular basis for security holes. So just give that a try, and hopefully in a few minutes, we should have some answers. All right, I think I can see some on the screen now. It looks like most of you are saying you have an average security in place. Some of you are still thinking you have a poor system, and it looks like only one of you thinks you have an excellent system in place. We'll talk a little bit more about what that excellent system might look like as we go forward in the webinar here. So one of the things that we've seen from our customers is dependency vendoring as a solution to a number of the shortcomings that they see with supply chain security. And dependency vendoring is all about taking your dependencies, the source code for all of your dependencies and their transitive dependencies as well, and then checking them directly into their code base. And that can help, but it has a number of pros and cons. Some of the good things around doing self-vendoring are like avoiding dependency conflicts. So you brought in that source code, you're going to build it yourself through your own build system, and you're going to be assured that everything will work together. So dependency conflicts are taken care of. That also means you're not going to break the build. So you won't be changing out those dependencies. They'll always build properly. That means you'll get a consistent deployment because your software will always build properly. That means everything from dev to test to production is going to deploy in a consistent manner. So all these things are great. And if something happens, if there's a key bug or a key vulnerability and the author is slow to patch that, you can even go ahead and address that yourself because you own the source code at that point in time. But the fact that you own that source code introduces a lot of complexity because now you need to build everything yourself. And that means you've got to have those operating system and language expertise on your team in order to be able to build every one of those dependencies yourself. That also means that if you're not keeping up with the latest versions of those dependencies as they're released, for instance, addressing vulnerabilities or addressing those bugs, your code can become outdated very, very quickly. And that can lead to security holes inside your product as well, or even what we call invisible vulnerabilities. And that's because you haven't yet built that dependency. It's just a source code. You may not be tracking it as source code, only as a built dependency. You may not be aware that there is a vulnerability inside your code base at this point in time. And then finally, unless you're keeping good track and organizing your source code properly, you get a lot of clutter. And that can lead to everything from slower code reviews to even making it more difficult just to check out the repository. So there's a number of pros and cons associated with self-vendoring. What we like to think of is the fact that our active state platform works as sort of a vendoring platform, a dependency vendoring platform for you, so you can avoid those complexities. What we do with the active state platform is to go out to all those open source repositories, be that Ruby Gems, be that CPAN for Perl, be that PyPI for Python, and pull in a lot of those dependencies, also from places like GitHub, obviously, as well. We bring them in on a regular basis, so they're always up to date, and we always bring them in as source code, which in many cases we vet as well to make sure that it's clean. We also link up with different vulnerability databases to understand whether what we're bringing in is vulnerable and then flag it as such so you understand when you ask for a vulnerability, what its current security status is like. And then we build everything on the fly from source code and then monitor those over time to make sure that what you've got is not only a pre-built runtime valid for the OSs that all of your developers use, but you can understand its vulnerability status, its security status as well. And then you can deploy that wherever you need, whether it be developer machines into your CI/CD process, pull them into your artifact repositories if that's the way you prefer to work, or deploy them straight into the cloud. So one single solution that can do all your dependency vendoring for you and avoid a lot of the complexity that comes with it if you did it yourself. So, just as a summary comparison here, if you're pulling directly from the public repository, yes, it's pre-built for you, so it avoids a lot of the time and resources to build it, but there's no guarantees as to the security. If you're working with a trusted vendor, say like a Red Hat or an Anaconda for Python or somebody similar, then yes, it's all pre-built for you. It saves you the time and resources. You can be pretty sure that it's secure, or at least you'll get a report from them understanding what its security is like. And the only drawback here is it may not be up to date. It takes time for those vendors to build and distribute their distributions. And that can mean you're not working with the latest version of the dependency that you might need. Finally, you can also go ahead and build it yourself, but that takes a lot of time and resource commitment on your part to make sure that what you're doing is being done in a secure method. So finally, we like to recommend the Active State platform. Nothing is pre-built. Everything is built from source. It's built in a secure manner using our secure build service. And Sean is going to tell you a little bit more about that and why we think it's very secure using the SLSA specification. Everything is up to date. We pull in things as and when they are updated within the public repository. And finally, since this is a service that you can leverage at any point in time, you don't need to deploy this on-premise, maintain it, or build it yourself. So very low time and resource commitment here. So with that, I'm going to turn it over to Sean to talk you guys through a little bit more about SLSA and the secure build service that we built from it. Sean?
Okay, so SLSA is a new initiative to address many of the issues we see in supply chain security. It stands for Supply Chain Levels for Software Artifacts, and it outlines a set of guidelines and controls to improve confidence in the software supply chain. It's run out of the Open Source Software Foundation by a cross-industry group formed of interested parties from the likes of Google, major financial institutions, software vendors, and more. There's also significant participation from the Linux Foundation and other open source groups, and ActiveState has been involved since its inception. SLSA defines multiple levels of compliance, 0 through 4, with each level representing an increasing level of assurance in the artifacts produced. To quote the SLSA team about SLSA, it's a security framework, a checklist of standards and controls to prevent tampering, improve integrity, and secure packages and infrastructure in your projects, businesses, or enterprises. It's how you get from safe enough to being as resilient as possible at any link in the chain. Next slide, please. In SLSA terms, an artifact is any asset which forms part of the supply chain at rest. So this could be source code tables on GitHub, build scripts for a particular build system, binaries like wheels or gems, or Docker containers. Any file or archive of files which form part of the chain between the original developers and the installation by a user. An attestation is a machine-readable statement about the provenance of an artifact. It's a document which outlines the artifact itself, how it was generated, by whom, at which time, and using which dependent materials. And these materials may include the state of the machine prior to building it, for example, a virtual machine or a Docker image, and the required software dependencies, libraries or build tools, and anything else that may influence the resulting artifact. SLSA recommends using the in toto ITE 6 format for attestations. At SLSA level 3 and above, it requires that the attestations be non-falsifiable, and that generally means by having a digital signature attached. Attestations also contain references to and secure hashes of all the materials used and the resultant artifact, such that everything is verifiably tamper-proof. Next slide, please. So for a secure build service, SLSA mandates a set of requirements for build systems to meet the various levels. At level 4, which is the highest, it requires scripted builds. Build scripts cannot be accessed and modified by external sources. It requires a secure build service, which means a dedicated service that runs on a minimal set of predefined lockdown resources, rather than a bunch of developers' workstations or other arbitrary systems that could offer a larger attack surface to hackers. It requires you have ephemeral, isolated builds. Every step in the build process should execute in a short-lived environment. In our case, that's containers. And our containers are purpose-built to perform one single function only, which is the build, and that reduces the potential for compromise. Builds must be parameterless. Users of the build service should not be able to directly influence the build output by modifying parameters while the build system is in flight. Builds should be performed in hermetic environments. So containers should have no external influences, for example, access to the network. This prevents, for example, dynamic packages from including remote resources, which are beyond the control of the build system. It also requires that builds are reproducible. Given the same set of inputs, the build system must be guaranteed to always produce the same outputs. Next slide, please. Okay, so we're going to run a little poll here. We'd like to know how you rate your existing build system against the SLSA requirements. We've added 6 of the requirements to the poll here, so please check all the results that apply for your build system. Yeah, so there's whether or not you're using scripted builds, whether you have a dedicated build service, whether you're using ephemeral and isolated environments, whether users can access parameters to change how builds perform, whether you're performing builds in hermetically sealed environments, and whether your build system guarantees reproducibility. And hopefully in a few minutes, we'll start to see some results. Okay, what have we got here? Okay, it looks like a high proportion of you have a scripted build system. It's not always going to be dedicated. Yeah, not so many. It have the ephemeral isolated build steps, and those are sometimes quite tricky to get together. Again, reasonable percentage with only parameterless builds, and that's good. None of you are currently building with hermetically sealed environments, and some of you will guarantee that you generate reproducible builds. So yeah, it's a reasonable set. Okay, so with the active state platform, one of the things that you can do, or one of the things the platform will do for you, is generate software bill of materials, which is something that's come out of the Office of the President of the USA. It allows you to know every component in your runtime. It gives you an overview of everything that you will have downloaded from a third-party vendor, in this case, Active State. It will tell you about the licensing on the pieces that you've downloaded. It will tell you about the vendor and supplier who supplied it, and it'll give you some limited information on the provenance. Next slide, please. So the Active State platform at SLSA level 4 is required that build artifacts provenance are verifiable and non-falsifiable. SLSA suggests that this be achieved via a digital signature, on an attestation in Toto ITE6 format. And the Active State platform can automatically generate these attestations for every artifact it produces. Next slide, please. So building out a secure supply chain for your consumed open source software can be expensive and resource intensive. Using the Active State platform to supply securely built and ready to use software artifacts will save you a lot of time and effort. Using our attestations, you can verify the integrity and security of every artifact you consume, guaranteeing that it has not been tampered with by a supply chain attack. For every runtime delivered by the platform, you can get a catalog of all the dependencies used to produce it, assurance that it has been built in a secure environment, same assurances across multiple operating systems, software bills of materials, and attestations. Combined with our command line tools, these features represent a simple and secure and cost-effective way to integrate open source software into your own builds. Okay, next slide. We're going to wander now into a platform demo. So I'm going to share my screen here. Okay, so I'm going to start with a view of the Active State platform and what a project looks like on the platform. So here I have chosen to build a project which is based on Python 3.10.5 on Linux for glibc 228 and above. We are going to include a random Python module that I chose here. And what you'll see is that given that all of these things that I've put in, platform has calculated all the dependencies required in order to build that particular runtime. So we can see that you can come to the download builds, and here you can see the status for everything that it built, and you can see the log files of when it built it. So I said we could get an SBOM for any one of these. So here's our project. The project is in my personal organization, which is Shawnell, and the project name is a test. Using our GraphQL interface, you can request an SBOM for your projects in a range of different formats. I'm going to do one in JSON format here. So here I just plug into this query that the organization name is Shawnell and the project name is a test. And then, whoops, what's going on there?
You have to reload the page, Sean.
Oh, yeah. There we go. Yeah, sometimes it doesn't work the first time. Yeah, so what I've requested here is an SBOM, and I've requested these fields in the SBOM, and you can see that it's actually produced the SBOM here, and you can see all of the content of what's in your runtime here. So we can see that we've got Python 3.10.5 supplied by active state, and here's a checksum of the artifact that you will get. So now I'm going to wander into dealing with attestations. So the active state platform can generate automatically generate attestations for every artifact as part of that project. So what I'm going to do now is I'm going to kick off a little tool here. I have that given my project, which is Shawnell, organization Shawnell, and project attest, is go off and find attestations for all of those and verify them. I'm going to kick that off now because it takes a little while. And in the meantime, I will show you what the attestations look like. Here's a sample attestation that came from that project. You can see that in the in-toto 6 format, you get a payload type, which shows you that it's in toto, and you get a signature. So this is the digital signature of the attestation that you can verify the content of the attestation against. You can see the payload here is base64 encoded string. So what I'm going to do is expand that out so you can see what's in there. Here you can see the attestation itself. You can see that it's an in toto statement. We have, this is what we're going to be building. So here's the URI to the source code that we're going to build. So we're building OpenSSL here. And here is the checksum for that source code. You can also see that we've listed the materials. The OpenSSL doesn't have any software dependencies of its own. So we're going to list the Docker image that we use to build it in. So there's a reference to the Docker image. And here's the checksum for the image itself. We then have, what did we do to build it? Well, we invoked our build script, which is just called build. And in this case, for OpenSSL, we didn't actually need any parameters at all. Those parameters are baked into the build system and they're not actually available to be modified by any users. We can also see the metadata about when it was built. So we can say when we started the build, when the builder finished, and then a descriptive invocation ID, which tells you about what we were building and the artifact ID that it generated. And then finally, there's the message about the actual artifact that we generated. So you get a reference to the artifact and where to download it from and the checksum for that artifact. So you can see that you've got details on pretty much everything that happened in the generation of that artifact. So let's go back here and we can see that our script has gone off and for every item in that project, it has gone and found the attestations for them. It has verified the digital signatures on them. It has then downloaded all of the materials and the references. So it's downloaded the source code. It's downloaded the build script. It's downloaded the artifact itself. And then it's validated the checksums on all of those. And then it's recursed down all the dependencies for all of those things as well. So everything that was in there and everything that was used to build everything that was in there is also been validated. So you get a supply chain validation there where you can actually see for everything that you've downloaded that we've actually proven that none of it has been tampered with between active state ingesting it and the artifact that you've been served with. Okay, that concludes our demo here. I will stop sharing and hand back to Dana.
All right, thanks, Sean. So we have some time now for some Q&A. So I'm just going to go ahead and pop open our Q&A window, and we'll see what questions you guys have entered here. I see a few of them here, but if you've got more questions, please go ahead and type them in. We'll just take them one at a time here. First one, hello, Sean and Dana. Wondering how Active State is different than others in your space, and who would you consider your top competitors? So we have a number of competitors out there that do various things around us. Nobody does exactly what we do at this point in time. Our biggest differentiator is the ability to automatically build everything from source code without you having to do any of the work. So you don't need to have any language or operating system expertise. You can come in and just pick the packages you need for the operating system you work on, and the system will automatically build it for you. If you did this through a GitHub or a GitLab or a Google Cloud Build or any of the other services, you would be creating all those scripts yourself. So that's one of our key differentiators. But obviously, those other services have that source code and mechanism to help you get off the ground and start building things. They're not quite at the level of security that we offer. Do you have anything to add, Sean?
Yeah, I would concur with all of that. I don't think that most of our competitors are offering the kind of the levels of security that we're baking into our platform, and some of the other assurances that are baked into our automated build system are just not available elsewhere.
All right. Another question here. What is the difference between attestations and SBOMs, and how would I use them in my development process?
Okay, I can take that one. So an SBOM is basically an overview of the software that's been supplied to you. It gives you a complete list of all of the artifacts that form up the software as it's been delivered to you, and it gives you some minimal information on, gives you at least the checksums and the licenses. So you can see then that the checksums validate, and you could potentially use that. That's a document you can download once and use offline as a reference for your software runtime that's been delivered to you. Attestations, on the other hand, are statements about the individual artifacts and go into a lot more detail. So they contain references to where you can download the artifacts from. Again, they're individual checksums, but also details on how they were built, when they were built, who built them, and also, it's got the checksums of all the dependencies in there as well. And you won't always see all of that because some of those things will be structural. They'll be build time only things. So for example, if you're using a compiler or something like that as part of your build chain, you won't necessarily see that in your SBOM because it's not been delivered to you, but it should turn up in the attestation chain. And you can use that in your infrastructure because you can validate that, and you can also then, if you choose to, follow the chain of attestations back all the way back to the build image and the scripts that were used to build it. So you can integrate that validation into your build pipeline, and to be sure that everything you're being delivered from third parties such as Active State have actually been built and in a secure way.
Great. Okay, another question came in. Can the output be exported to be used in other systems?
I can take that one as well. Yeah, so we have some functionality in the platform that allows you to take our artifacts and host them in your own artifact repository. So for example, you can take wheels that have been built for Python modules by our platform and host them in JFrog Artifactory. So that's a way that you can consume our artifacts and basically host them yourselves, and then use them however you want, however you would normally use artifacts of that kind.
All right, I guess similar question. Is this functionality available via an API so I can integrate it with my dev process?
Yes, all of this information is via our APIs. So the tool I demonstrated there is just literally stitching together some of our APIs. The state tool is the recommended way for you to consume our artifacts direct from us, and but that again is just accessing APIs that we have. So basically, as long as you have appropriate access to the Active State platform by having an Active State platform account, then you can access these APIs directly.
Great. Okay. Another question I have a free trial. I noticed that you call it vulnerabilities. If I had the paid version, would these be remediated? So, one of the great things about our upper tier levels, like our enterprise level, is it includes something called a managed build. So that's where we take care of all the dependency management tasks for you, including things like remediation. So if you have different policies around, high or critical vulnerabilities can't be in my runtime environment, that would be something that we would take care of for you. We would remediate those for you, let you know, and you'd be able to download that updated runtime and redeploy it. So significant way for you to avoid dedicating your own people, your own time and resources to managing those dependencies within the runtimes that are critical for your organization. Really, that just outsources it to us through this managed build service, and we will take care of all that for you. Another question here, when will you support Java and or JavaScript? So yeah, we've heard this before from a number of different users and our customers as well. We are constantly adding new languages to the platform. Currently, we support things like Perl and Python and Ruby and our own Tickle. We also have things like PHP on the go, where we brought in a lot of those packages, haven't quite exposed that to you so you can build your own PHP just yet. But these things are all in different stages. So we're definitely looking for some good lead customers, some good use cases around, why you think the platform would be a better place to manage your Java or JavaScript runtimes. And if we can get some lead customers there, that'll bring things onto the platform that much quicker. So definitely get in touch with us if you have a good use case around those. Another question here, am I able to run your build service without internet access? Sean, do you want to jump in?
Yeah, sure. So at the moment, there is no kind of on-prem solution for using the Active State platform. However, as I mentioned before, you can host our artifacts in your own private repository. So one of the ways that you can do this is actually build everything on the Active State platform and then host the resulting artifacts on your own systems.
Kind of a hybrid system there.
Mm-hmm.
All right, another question here. Does any of our code live on your systems? So we've heard this before from a number of different customers. There are instances where customers of ours have their own version of a dependency or their own dependencies that they built themselves. And those we can accommodate by uploading to our system. But in general, we don't take your entire software product's code and bring it into the Active State platform. That's up to you to build on your own. What we're really focused on is creating that runtime environment on which your code will run. That's the thing that we want to build, and that's what we provide on our own systems. All right. I think that's the end of our queue. I'll give you guys a few more seconds if there's any other question you want to ask at this point. If not, you can always reach out to us. There are certainly contact forms on the activestate.com website. You can ask us anything after the fact. Going once, going twice. All right. So next steps, if what you've seen here looks of interest to you and you want to get a deeper dive, please contact our product experts. Just click that link and we can take you on a more in-depth tour of the ActiveState platform and how it might address your requirements. If you're interested in SLSA and supply chain security in general, we've got a lot of assets. There's at least a dozen of them on that link. So if you click that link, you should be able to find a lot of blogs, a lot of white papers, a lot of data sheets that can give you a pretty good overview of SLSA and supply chain security as it's evolving. And then finally, you can always try out the ActiveState platform for free. Just click that link, enter your email address, and you can sign up for a free account and give it a try yourself, see how it works for you. So finally, we'd invite you please to give us some feedback on this webinar. There's a little survey that you can take that just answers a few key questions. And that's really to help us understand whether we're addressing these things in a manner that's appropriate for you guys. And if there's something that you'd like us to see changed in the future, please let us know. We want to make these as useful for you guys as possible. I think that's it for today. So I'd like to thank everybody for attending, and we'll see you next time. Bye for now.